So yeah, MG will be on here. He is going to be talking about rapid prototyping chaos. So for those of you who have followed MG and his work, he has done a significant amount of really, really interesting projects with hardware, including backdooring everything from charging cables to power bricks to you name it, he's probably backdoored it. And so he has a few projects that are out there that you can purchase, the OMG cable and Demon Seed. You may have seen some of his POC videos or heard him on our podcast in years past, but he is here to talk to us about rapid prototyping with hardware. So yeah, it's almost about time, I guess, in a minute. Everybody retweet out about this if you want to. And
so MG was one of our initial thugs from the thug crowd, and yeah, let's hand it over.
All right. You hear me?
yes.
Oh yeah.
We are good to go. I'm gonna switch over to my desktop real quick and share that. This is my About Me slide. That's really all I got. I'm going to talk about the last, I don't know, about year worth of rapid prototyping I've done, because it kind of changes the way you think. And here's just a stack. This is actually about 6 months old now. A stack of all my failures, like all the PCBs I've made that just didn't work. But before we get into there, I'm gonna go back to 2017, before I knew how to do any of this. I decided I wanted to make an exploding USB drive. Cool idea, right? But let's cross it with a USB rubber ducky because, you know, naturally, had no idea how to do any of that. So I sketched the basic schematic out on paper. That's literally what you see here. And this is the physical layout of the board. It's it worked, right? Like there were a lot of software packages out there for designing things that it was just too complex. It was just more of a hurdle than I wanted. So I was going to use some paper, right? And didn't know how to make PCBs, but I found these cool grids of copper squares called SMT pads, and it's what I was using to kind of construct this very first prototype using copper tape and stuff. It worked, kind of, you know, assembled it, and that was the first prototype here. I call this Mr. Self-Destruct, right? And here it is, you know, chopped off a USB connector from an existing flash drive because, you know, where do I get USB connectors, right? This had the little bonus. If we go back up into the schematic over on the right is basically kind of like a relay that would allow an additional pin to, I want to be careful here, but basically that allowed the fun activities to happen later on. That was really the only addition. The rest of the circuit was basically just an AT-tiny that would bit bang. Bit banging is where you may not have inside the silicon of the chip the ability to do a certain thing. In this case, this chip didn't have USB, but we can turn on and off the pins really fast and emulate what USB is expecting on those lines. The rest of that circuit's already, you know, well established. So I just took that and added a little high power relay to it. And ultimately, what we got was this, plenty of room inside here for all the activities. And I don't have sound shared here. Let me see if I can do that real quick. Screw it, whatever, we're good. Anyway, this was the first Mr. Self-Destruct, right? So you plug it in and Ducky payload kind of unwinds on the screen, opens your browser, and opens a video, and you see a little Jack in the Box here. You hear the Jack in the Box sound. This is what you would hear if I had sound shared, but I don't. And it goes for a little bit longer than you'd expect because we got to build tension, right? And then eventually, pop, a bunch of confetti flies out. Yeah, that's cool. Put other things in there like smoke bombs, right? Looks pretty cool. Ultimately, you know, that was pretty cool. What else could I do with it? And I started playing around with this basically really tiny ducky, which, you know, the actual USB rubber ducky has way more space and it's a lot faster, but everybody knows what a ducky is. So I'm just using it as a general term here. I decided to shove the demon seed inside of a cable, and that's where we got this, right? My cable didn't actually work as a cable. It just looked like a cable. It's not really a cable, but you know, there's always room for improvement there. Basic idea there, right? Yeah, it was chunky, it was big, it's, you know, the very first one, right? And might as well shove that into a USB condom at the same time, right? Why not? Like, that makes sense. Everybody looks at, oh, cable, this is why we need condoms. I'm like, cool, you need condoms, let's fuck up your condoms. Same concept, right? I'm not gonna let all of these videos unwind because that will take a while. Polish this up a little bit more, and suddenly we've got, skip forward a little bit. Same concept, but now it charges. We're not getting data sync yet, but it charges, right? Which is an improvement and visually looks a lot better. It's not exactly a match to an Apple cable, but it's close from a distance. But you know, if we want to use this for actual offensive tooling, it's probably not going to pass when it's in the hands of a target. It looks cool on stage, but that's about it. So about a year later, so that was all 2017, very early 2018. About a year later, I decided I wanted to kind of ramp it up. Actually, here's a good comparison. It's a close match, but you can see this this physical, the large connector here on the right. On the top it's a bit chunkier, it's longer. It's a close match, but it's not perfect. Anyway, a year later, I decided I wanted to chase that further. You know, let's get data passing through, so it's a real cable, right? It works like a real cable. Data passes, charges, but also, you know, let's update these payloads remotely, because you know, that's kind of what I would want to do as an attacker. And rewinding to what you just saw, every time you want to update a payload there, you have to plug the thing in, update it. You know, cool. And it will just play onto your computer as you plug it in. You can put a delay, but it's much like a rubber ducky in that sense. You plug it in and then it starts. But in addition to updating them remotely, it would be cool to have a trigger that's remote. You know, how do I do that? I have no idea. It's just, I want to accomplish this. How do I design that? And about a year ago, year and a half now, decided, okay, software, when you approach it, at least the way I approach it, it's really quick to just change something, compile, see what breaks, see what changes, and just keep doing that over and over and over. That's, you know, a matter of seconds per cycle, per spin. With hardware, you know, creating a PCB, weeks roughly per spin. You got to design it and you send it off to some manufacturer. Now, there are in-home methods for doing this. And that's what I kind of started exploring there. The older one is using acid to etch copper off of a board. So FR4, or there's multiple types here, but I'm using FR4. Basic concept here is you've got copper, at least on the top layer, sometimes also the bottom layer. This is the number of layers your PCB is, so this is a 2-layer. In between, you've got some fiberglass and epoxy mixture that's just non-conductive. That's the basic of what a PCB is, and ultimately, those get turned into PCBs, right? And here's a raw FR4 panel, right? It's just all copper sheet on at least one side, and then that yellow you see is the fiberglass mixture. So here's a mill cutting out traces. Instead of using acid to remove portions of the board, we're just using a mill. And this is quick. It's a lot more accurate, more repeatable, in my opinion anyway. And that's what I decided I wanted to start chasing. You can see the process here. You mill it, solder things up, and boom, you got a circuit, and it's a pretty fast process. Maybe an hour roughly per spin. Depends on what you're making, how big the board is, the complexity, but that's what I wanted to chase. I'm like, cool, I can now take my approach of rapid failure to learn how to make these. So I decided to get one of these Bantam mills. I think they're like $2,400 now. There are other mills out there that are much cheaper. I specifically went for the Bantam because the software flow is really easy. You just dump the file out of your design software, pull it into the Bantam, and it abstracts a whole bunch of things that are kind of connected to a CNC, traces and what is it called? Speeds and feeds, the mechanics, the physical nature of your tool moving. A lot of that is abstracted into pre-made libraries for you. So it's like quick and easy. And, I can save a revision to my PCB and pull it into the Bantam software, in seconds, hit go and boom, new PCB is ready to go. So on the left, I've got KiCad. This is just PCB design software. This is the Mr. Self-Destruct at the time I pulled this in. I'm like, hey, that's going to be like my hello world for the Bantam mill I just got. And the red layer is the top layer, the green is the bottom, and pull that into the Bantam software, right? And probably took an hour or two of back and forth, and eventually, this pops out. It's like, cool, this actually worked. Would fit a cable pretty nicely. So great. Hello world. Let's chase this deeper. Like, let's get finer traces. The mill is advertised as not being able to do these smaller footprints, but we could definitely chase it. So lots of testing here, different depths, just really repetitive iterations just to see where the boundaries on this mill are. This board looks wet because I've got it covered in oil. FR4, it's fiberglass, and when you mill it, that's glass dust up in the air. So you got to have some way of either rapidly vacuuming that out, which I would later upgrade to, but oil, really, really heavy oil, kind of painted on, would do a good job of trapping everything. So more testing, right? Test. And here's some microscope shots. On the top, this is just a minor difference here, but you can see the traces, nice and clean on the bottom, really rough on the top. And the difference between those two is just the tips of these bits right here. The one on the left with the little sharper tip was making these nice clean cuts, and the slightly rounded one would make these rough cuts. And you don't really know. And I would always buy the cheapest tips because they're called end mills rather. I was breaking these a lot, and I can't pay $25 per. I'm gonna get a 10-pack for $20. So figuring out what is a good process here took a lot of iteration and playing around. And ultimately, here's a much more detailed board that I was able to get out of this after doing these tests. And that's great. We've got copper and clearly places to put our components. We can solder these on, it totally works, but we're missing one key thing, and there was no real good solution. So I started playing around. Solder mask, right? So that's that green or whatever color you're used to seeing. Basically, it's a lot like UV cure nail polish, right? There's like solid film and other stuff, but for the most part, UV cured gel is the basics of most solder mask. One common way of applying that is, put a sheet down and you're using sheets of like transparency film that have like black printed on it to block off UV. But, we've got a mill, so why not just remove that, right? So I was able to get pretty reliable results here. And here's the basic process I ended up settling on. It's first you cut out your traces. Put some tape down. Apply the goo, it's gel right here. This is the UV gel. And then scrape it with a razor blade. The Scotch tape I put down here kind of acts as a shim, so I get this nice thin layer of gel. And I take a UV LED. This is a really big panel. I started with like a UV flashlight, but I didn't like waiting. So, I got this, I think it's like a 40-watt panel that just happens to fit inside of the mill. Perfect, right? Let that go for a little bit, and then out pops a cured layer of solder mask. And then I started just using the same engraving bits here to remove the cured solder mask from the areas I needed it removed over the pads. And, it worked pretty well. But ultimately, I discovered these things called drag tips. And again, expensive, but I talked to a somewhat local tool manufacturer and convinced him to make a really reduced version. And this is kind of what popped out. And this is what it looks like. So a drag tip, it's got this engraving tip mounted inside like a spring mounted collet around it. So that allows the softer solder mask to be eaten away, and the copper is harder, so the tip kind of stops and hovers over. You can't sit for too long, but it buys you more time so that you're not cutting through that really thin layer of copper quite as easily. And this made the process a lot faster, and that was great. And that was kind of the result, right? You get this, and then you cut it out. Cut the holes, cut the perimeter, pull it out, and there we go. That's that's the basics of what this process looks like. Now, one problem with a lot of these is basically one problem with all homemade PCBs is the vias. Vias are what transfer conductivity from the top to the bottom. So you got a hole that goes through, and the easy way is to just put little tiny wires and solder them into place on both sides. And that's kind of what you see here, those little blobs of solder. I started playing around with a couple different other methods, using conductive epoxy and stuff like that. These all were interesting. It's not super reliable all the time, depending on how much current you're passing through it. But again, you can produce some really good looking results with it. So, here it is. The vias are hidden under that solder mask, and I'm playing around with a lot of different designs and accidentally did a cross section, but it was cool because you get to see that the conductivity of the top layer passes through to the bottom layer. That's what we were going for. This isn't good for just making little prototypes and whatnot. When you're designing things, breadboarding, for instance, breakouts are great, but that restricts you to parts you can find breakouts that match, right? But what if I just make my own breakouts? Cool. Like, here's this chip that I didn't have a breakout for. It's fairly common. You can find breakouts that match this, but again, I also don't have to wait for delivery, so that was cool. I could just make these in a day. Or you can make, custom little breakouts. Like, I wanted this specific component, this really tiny component that wouldn't fit in a breadboard or on here. I wanted that inline on USB for some testing, and this is what I got out of it. You can make full scale, full circuit prototypes. We can also make these little breadboard expansions. So again, you've got some really small components, you want to test them on a breadboard. Well, how do you do that? Especially when you want a very customized breakout. So, here, this is how, right? And we get real small here. That one on the right on the red, that's a BGA component. And there's a lot of different ways to go about it. I started playing around with the solder mask define on the left, right? So instead of bringing your solder mask up to the edges, you actually bring it over the copper so that you get smaller detail. And that allowed me to do things like this, right? So this I think there's a 0.4 millimeters between each ball here, center to center. 0.4 millimeters, and that's really tight, and you can't really pull traces between those balls, but you can do interesting tricks. Like, you can see here, there's a ball that's missing because I run a trace underneath and I use the solder mask to kind of insulate that layer. So we get this very first prototype. This was OMG cable, V1 that dropped in, what was it? I think it was 2019 February. Worked barely. Had a lot of failures. So many different attempts at this. Just in that first month. I started in end of December and early February. So I think it was like 5-6 weeks to go through the whole process to get the very first prototype working. It just barely worked, and that's kind of what you see here. That's a little over a month of playing around. V2 started playing around with different approaches of programming it. I lost track, but this is several months later, getting closer to what would ultimately become the production version of this. Now, again, the OMG cables, that's the wireless connectivity. It's got 100 times more space. I really wanted to see how far I could take the concept. Like the AT Tiny with its 8K of space is cool, but let's add like a meg or more. Let's add an 802.11 radio. Let's put a web server in this thing. Let's just see how far we can go. And that was the point of the OMG cable, right? And we're gonna need to start playing around here. We're getting close to production. I need to solder a bunch of these together. Let's get a toaster oven and mod it. And that's gonna allow me to solder a whole bunch of these OMG cable components onto boards using solder paste. Basically put that in the oven for a very controlled period of time, and it allows the solder to melt and all your components get attached. Get the family involved too, because things are scaling up. More of the family. This is in DEF CON, like nothing ever stopped. It was barely done in time. This is me still assembling OMG cables in the hotel room and like heat curing components and stuff. But before DEF CON, I had this idea of like, hey, let's also make a whole bunch of the AT Tiny versions. They're really low gray, but they're interesting to people. It still gets that concept of a malicious cable. It's not really good for field use, but it looks like a USB cable, and it's malicious from a demo perspective, right? But cool, let's make that on a whim. It was like a month before DEF CON. I'm gonna make a whole bunch of those. That's kind of what they look like. Hand assembled these. This sucks. But basically there's solder paste on this panel and a whole bunch of little components. This is my wife helping with tweezers, putting every little component on every little panel. And here's me programming them on the airplane. We would call these demon seeds to differentiate them from the OMG cable. But of course, nothing's ever done in time. Here's a whole group of people awesomely helping me in a hotel room pack all of these into the little drug bays that I chose to use for the packaging. And that was great. Everybody loved it. I was not expecting that. These little $20 bags of, handout kit. Everybody was asking me after DEF CON, like, oh, I want to buy these. I want to buy these. And it's like, well, this was not something that I thought was worth like mass producing and selling. So I thought, what can I do to make this better? So I wanted to get a basic wireless trigger functionality and get data pass-through working without really adding any components. And ultimately I had to add, I think it was 2 more resistors to the entire circuit. I don't have to put a USB switch, to put an antenna, any of this stuff on there. And it works. The antenna like kind of barely works, right? But that's the point. It's more of an educational experimental thing to play around with, which was what everybody likes. So that's kind of where the V2 version, and that's what this board would look like. And I made this kit, and Hack5 is like, yeah, you can sell it on our site. I'm like, great, because I don't care about fulfillment or anything like that. I just want to make kit. Then you got these pins. If you can see right here, bottom left, there's like 6 pins. Needed those to program it as part of the kit, right? I had to sort and count 6 pins per bag. That sucked. So made this little tumbler that's got a vibrating arm, vibratory feeder is what these called. 3D printed this. A lot of failures, but ultimately, we got this working. It was great, and it would dispense 6 pins at a time in a little Dixie cup, and we put all the other parts in, make a whole bunch of little bags. You can see it going on right here. Packed a whole bunch of demon seeds into Hack5 bags. Great. Come on, scroll. Pick and place. So instead of tweezers, let's use the machine to place these little components on board. So started here. Basic concept is, starts off, come on, move a little faster. So this machine uses cameras to see what it's doing. And this little white strip of paper here contains little components. The camera sees it, lowers a little syringe, uses suction to pick them up, and then it places it onto the PCB that already has paste on it. I'm testing here by placing it on double-sided sticky tape. Slow, yeah, it kind of worked. First results, things were not aligned. Ultimately, we got it there, and it was fast at this point. You know, a lot faster than we started. A lot of modifications, and we can see it, you know, rapidly placing components onto the boards. Like a field of panels here. It worked. You know, the addiction keeps going of speed more. So, you know, here I'm using a mill and a 3D printer to make these feeders, and feeders would feed instead of putting these strips of tape on the table and have to carefully calibrate where it is. Just have a feeder, just kick a little component at one at a time, and just goes back and forth. Oh, this was Christmas vacation with the family in a hotel room. We're like, well, we got to pack all these OMG cables, which had just come back from the factory. Those components are so small because everything's more complicated here. We had a factory do it, and we still had to test them and bag them. And, you know, that's basically what I was doing in the hotel room when the kids went to sleep. And of course, nothing is complete without a really cool logo. So a year ago, I saw this cool Industrial made this awesome shirt. I'm like, man, that looks cool. USB logo, I should do it like this. You know, I was thinking OMG, I'm like, I need a cable design, right? My wife said that just looks way too phallic. And I'm like, oh yeah, I see it now. That sucks. But, you know, this was my reply to her. Tweak the M. Threw it away, you know, came back months later when Demon Seed came back. I'm like, wait a second. Maybe it's not an OMG cable logo. I mean, this is the Demon Seed logo because now the weakness suddenly became a feature. I said, Industrial, come fix this for me. Like, this is crap. And this is what he made. So this was the Demon Seed logo that popped out, and it was great. I'm like, holy shit, this is perfect, man. And then OMG cable, of course, needed its own logo because totally different result. And that's what came out. And here were a lot of, you know, revisions he was making. But anyway, that's kind of like the end. And I still wanted to leave space for questions. Do we have any questions?
Let's see. MG, that was sick.
That was awesome.
I always
I couldn't hear you, sorry.
I said it was sick. I always love your iconography of razor blades just around the place.
Nice. All right, there we go.
Oh yeah.
So, do we have any questions?
Does anybody in the chat have any questions for MG here? Dade says, show us the Furby.
Oh man, I have to go running in the house to get that. The Furby, I have so many ideas. Yeah, the Furby is this horrific. I mean, we just want to make the Furby as ugly as possible and just horrible as possible. For instance, one of the features is that just popped into my head, I think it was the other week, is every time there's a general sentiment expressed on Twitter that is negative towards offensive security tooling, I would like the Furby to release actual flies from its mouth. So I've got all of that working except for the sentiment analysis, but you know,
highlight them.
Skillsec says, what's the next step? What's your next big idea?
I never know. That's the thing. Everything is this, like I presented this in a fairly linear way, but the reality is all of those were in tandem and they would come up and go down off the, you know, the work table. And I just have this table in my mind of just things that could be, or things that I don't know what they're for. I just know I need them for later. And they all just kind of assemble into whatever pops out. I've got some really cool stuff that we have been chasing on the OMG cable that, you know, hopefully we'll be able to show off soon. yeah, I mean, there's refinements as well. I mean, I had like a 40% manufacturing defect rate on the first batch of OMG cables. So I think I've got that worked out now. But I mean, that was huge. If anybody's into manufacturing, like, you know, you've got like maybe 1% or 2%. I had like 40%, and that sucked. But chasing things like that has been consuming a lot of time, and all this stupid shit around like business and like registering, and I hate that stuff. So
Yeah.
thank you, Hack5, for offloading some of that for me. It's great.
No, so
And if everybody wants to like get some of these things or just look at some of the stuff, go deeper, I have archived a lot of this on o.mg.lol. mg.lol is where I got the blog. o.mg.lol is where I got like the products. If you want to just kind of look at what's in that landscape, this was a very quick speed run.
Awesome. And I guess the Demon Seed kits for education are for sale as well. The cables are for sale for use in red teaming.
Significantly different. I think you can go check. I'm gonna show on the screen, the stream, but yeah, o.mg.lol if you were wanting to look up either of those.
Hell yeah. Shout out to Kevin.